This is what a sound wave sounds like, but what does a sound wave look like? Well, the air through which the sound wave is traveling looks something like this. But if you want another visual representation of the sound, we can hook this speaker up to an oscilloscope and it gives us this graph. We say that this shape represents the sound wave because if we focus on a single molecule of air, we see that it moves back and forth just like a sine or cosine graph. The horizontal axis here represents time, and the vertical axis can be thought of as representing the displacement of that air molecule as it oscillates back and forth. The center line here represents the equilibrium position or undisturbed position of that air molecule. Typical sounds have frequencies in the hundreds or even thousands of hertz. For instance, this note, which is an A note, is causing air to oscillate back and forth 440 times per second, so the frequency of this A note is 440 hertz. Higher notes have higher frequencies, and lower notes have lower frequencies. Humans can hear frequencies as low as about 20 hertz and as high as about 20,000 hertz. But if a speaker were to oscillate air back and forth more than about 20,000 times per second, it would create sound waves, but we wouldn't be able to hear them. For instance, this speaker is still playing a note, but we can't hear it right now. Dogs could hear this note though. Dogs can hear frequencies up to at least 40,000 hertz. Another key idea in sound waves is the wavelength of the sound wave. The idea of a wavelength is that when this sound is traveling through a region of air, the air molecules will be compressed close together in some regions and spread far apart from each other in other regions. If you find the distance between two compressed regions, that would be the wavelength of that sound wave. Since the wavelength is a distance, we measure it in meters. For this kind of graph, the distance between peaks represents the wavelength of the sound wave, not the period, because it would be measuring the distance between compressed regions in space.